All right, so this first one is your partial fill-in, okay? It gives you part of the statements and part of the reasons. So instead of like having just one all-side blank, it's a little bit of both.
That's how the test is going to be.
It's a combination of two things. Like some are, like the algebraic one is open-ended, and then you're going to get where you have to like solve and explain.
Oh.
And then there's this where, I think it's the whole right side. I'm trying to picture it in my mind. I think it's all the reasons that are blank. But this one says, okay, so it's giving you obviously the statement that starts with MA is equal to TH. That is where?
It's a given.
That's the given, okay? Which is here, okay? That piece of information, I would also go as far as to say it probably is useful to mark it on your diagram if they give it to you, okay? If they give you a diagram, not all of them have them, but. Then the second thing says reflexive property of equality. So what is a reflexive property? Yeah. Good. Anything that equals itself. So like if I just used 1 and 2 to gather that information, it's kind of hard because I could say that anything equals itself. But if you glance at what's next in 3, what do they do in 3? So they add AT to both sides of the equation, right? So before I do that, I'm going to state that AT equals itself, and that's the reflexive property. So this would be AT equals AT, because then they add it to both sides of the equal sign. And what's that called? When you add something to both sides of the equal. Addition, property of equality. Okay, when you add the same thing to both sides of the equation. 4 says MA plus AT equals MT, and AT plus TH equals AH. What's that? Good. Segment addition postulate, or SAP, okay? Which says that the whole, the MT, is equal to MA plus AT. That's the whole is equal to the sum of its parts. And AH is equal to TA or AT plus TH. So again, the whole segment is equal to the sum of its parts. Now it says substitution property of equality, but I also usually stop at what? How do I know when I'm done with a proof? When you get the statement that is the proof, right? Which means
The last one must be MT equals AH.
Yes.
Would you consider this an easy one?
yes.
Are you for real?
Yes. Yes. Two-fifths of it are the given and the proof statement.
No, but like if it was all empty, would this like
If it was all, first of all empty compared to partial fill-in, I would not say all empty is ever easy. But all empty, this is it's not terrible. This is not hard. It feels hard if it's all empty right now, but eventually you will get better at them. And then in the long run, this would not be. You don't have that option.
Then you get
Yep.
which
No.
are English proofs in chapter 3?
Oh, yeah. Long time. All right, 2 says use the given information to prove this statement. So this time it's completely open-ended. It gives you measure of angle 1 plus the measure of angle 2 is 90. Measure of angle 1 is 59. Where do we start? Marcy, you had your hand up first, so where do you start?
I put that m angle 1 plus m angle 2 equals 90 and m angle 1 equals 59 are given.
Good.
Do we have to put both on the test? Yes.
Yes.
Thank you.
Okay. So again, if I wanted to label it, I could already add in here that this is 59 degrees and that combined this is 90 degrees.
And then I substituted at 59 degrees for m1 into the m1 equals m2. I mean m1 plus m2 is 90.
And that is
Well, 31.
substitution.
Is those gonna be the same order?
Yeah, that one would need to be the same order.
Then I subtracted 59 from 90 and 59 from itself. Yeah, I did get 31. That's so good.
Good job.
So how come you change the m angle 1 to 59?
Because m angle 1 equals 59.
Why can't you just keep that as m angle 1?
Because I can substitute the value in for what it equals.
But you just said we know.
Shh.
Exactly.
You can substitute the value, because we stated angle 1 equals 59 degrees, everywhere there was an angle 1, I can literally put the 59.
You can't take M angle 1 for 90.
Exactly. Wrong. It says
What's
right there.
90 minus?
Okay, chapter 2, section 6 is proving angle pair relationships. So we're going to learn a couple more things about angle pair relationships, and then we're going to use it in proofs. The first is, obviously we talked about this yesterday, but there's two, additional to the 2-column proofs, there's 2 different kinds, a flow chart and a paragraph. A flow chart literally uses boxes and arrows to show the flow of a logical argument. So it doesn't have to be in a linear path. You could have written in the beginning, something given, drawn an arrow to something else with a circle of the next step, drawn a circle to the next step. That would be a flow proof. And then a paragraph would literally be like a sentence, like because the measure of angle 1 plus the measure of angle 2 equals 90 degrees, and the measure of angle 1 equals this, I can substitute that measurement in for angle 1, and then I can subtract from both sides to get that the measure of angle 2 is 31 degrees. That would be a paragraph proof, so more like a conversation that you would have with somebody describing what you know and why you know it. Jonathan.
Is it kind of like the counterexample we use for conjunction?
No, these are just like a proof without the structure of the 2 columns. That's all. Santi.
So basically, a paragraph proof is in words.
It is in words, yep. All right, theorem 2.3, which the number is not important. You might see it, but it just means it's the 3rd theorem mentioned in this chapter. What is important is its name is called the right angle congruence theorem. And it says all right angles are congruent. If you don't remember the name of the theorem and you're using it in a proof, you could literally write out all right angles are congruent.
All right angles are congruent.
We put it as acronym?
No.
RACT.
No. Yeah, no. Don't start making up acronyms that don't exist. Yeah, no. All right, so this one is a proof by using a flow chart, okay, of what we just came up with. So this is saying, given angle 1 and angle 2 are right angles, prove angle 1 is equal to angle 2 without using the theorem that we just did. So this is like if you wanted to prove that theorem. So if I wanted to set it up as a flow proof, I can start with my given, angle 1 and angle 2 are right angles. Then what do we know about a right angle? What does that mean? They're 90 degrees. So I can say angle 1 equals 90 and angle 2 equals 90. And the reason we know that is because of the definition of a right angle. So then if angle 1 equals 90 and angle 2 equals 90, then angle 1 equals angle 2. And your book used transitive here. I would have allowed substitution as well because you're substituting a value in, or you're taking out a value, okay? So I wouldn't have marked substitution wrong, but the better one is transitive. And then if they're equal, they're congruent, and that's the definition of congruent angles.
Is it basically just the 2.5 with boxes and arrows?
So this is is it 2.3, you mean?
It's the same thing as 2.5.
It is,
With
oh, yeah.
boxes and arrows.
Correct, yeah.
So why
You're
do-
saying section, less than
Do
2.5.
you have to do the boxes and arrows?
So if it says to prove this using a flow chart, you want it to look like this. If it said to prove it using a paragraph, you would use words. And if it said 2 columns, you would use the 2 columns. Yeah,
It doesn't matter if you go sideways or downwards.
nope. As long as the arrows take you in the direction you want to go. All right, so example 2, right angle congruence theorem. Now we're taking that same thing, but we're putting it in a 2-column proof. So we are proving all right angles are congruent, given the same information we just did with the flow chart. You're given angle 1 and angle 2 are right angles, and you want to prove that they are congruent. So if angle 1 and angle 2 are right angles, where did that information come from?
Given.
This is given. The measure of angle 1 equals 90. The measure of angle 2? Definition of?
Congruent.
Nope. Right angles. Right? If we say they are right angles, so they're 90, or they are 90, so they are right angles, that's the definition of right angles. C, measure of angle 1 equals measure of angle 2. Nick? Transitive. Okay, and again, if you had put substitution, I would have given it to you. And if they are equal, they are congruent is...
Congruent.
And you could literally put definition of congruence. You could put definition of congruent angles. Either of those would be fine. Yeah.
Excuse me.
Hang on.
In the future, like, if we ever have like the transitive, right? Then does it have to be transitive, or is it, or like some
I would have given you substitution of that because there's actually values involved. If you're strictly saying the measure of angle 1 equals the measure of angle 2 and you're only talking about objects and then 2 equals 3, so then 1 equals 3 and there's no value involved there, that's transitive. But if you start to give it like a numeric value or something like that, or you're replacing more than just the if and then it's substitution. Yeah. From here, if like let's say in the future, which I'm trying to remember what the next example is. Yeah, let's say the future, it said just the given and the prove. We literally can go from given to prove, and my reason is the right angle congruence theorem. You don't have to do any of the steps in between. Yep, so we're just proving it. So if it ever says like prove this theorem, it means you can't use that theorem to prove it. Go the long way around. But now that we know that theorem, you skip those steps. All right, theorem 2.4 is congruent supplements theorem. So the last one was congruent right angles. This is congruent supplements.
So I assume it's 180 degrees.
Supplements are 180 degrees, but this says if two angles are supplements to the same angle or to congruent angles, then they are congruent. So if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, then angle 1 and angle 3 are congruent.
So is it always going to look together for angle ones?
Not, I mean, it could be the same angle or it could be two congruent angles. So like if 2 had a vertical angle and we linked 1 to 2 and 3 to that vertical angle, it would still be congruent because, oh, well, we haven't gotten there yet, but vertical angles are congruent. You'll see that. We'll do that at the end.
But you say all vertical angles.
Yeah, it's part of the, like we're going to get to that today. It's like in 3 slides. All right, so this one we're proving that theorem, which means we can't use that theorem, okay? We're going to prove it the long way. It says prove that two angles are supplementary to the same, that are supplementary to the same angle are congruent. My given is angle 1 and angle 2 are supplements, and 2 and 3 are supplements, and we want to prove 1 is congruent to 2. So angle 1 and angle 2 are supplements, that is given, as is 3 and 2. Those are both given. Angle 1 plus angle 2 equals 180, and angle 3 plus angle 2 equals 180. Good. Definition of supplement. And you could put supplements. You could put supplementary angles. Okay. 3, angle 1 plus angle 2 equals angle 3 plus angle 2. So this one, this is where it's tricky. You're replacing more than just one thing with two things. This is substitution.
And the next one's transit.
Nope.
I mean, the next one's syllogism.
Nope.
Wait.
Law of syllogism is never a reason in a proof. What happens from 3 to 4?
It gets rid of the 2.
And by get rid of, in math we mean? Subtract.
Good job.
And usually I would say there's even a step in between this that says angle 2 equals angle 2. And that would have been what? Reflexive. Good. So we didn't need it. They didn't have it there, but sometimes you'll see it there before we subtract the same thing from both sides. And from 4 to 5 equals to congruence?
Definition.
Good. Definition of congruent. Congruent angles or congruence.
Can I put depth of congruence?
Sure. Mm-hmm.
So if we did like that extra step for like the reflexive of M2 and M2,
Yeah.
then like wouldn't that also make the transitive? Because if you know that if M angle M and 2 whatever, both of them equal the same thing, then you can just take it out because you're adding them.
But that's if you had said the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, then angle 1 equals angle 3, that's transitive.
Yeah.
But here we took 1 and 2, that was equal to 180, and 3 and 2. We replaced this, and so you're replacing more than a singular object, which is why it's substitution. If I'm replacing one angle with one angle or one segment with one segment because I can link the two together, that's transitive. But if I'm replacing a value with two things like that, like what it equals, then it's substitution.
I meant like the one after where it's like subtraction.
But that's not transitive. It's not saying 1 equals 2 and 2 equals 3. It's saying 1 plus 2 equals 2 plus 3.
Since it has the plus, it's not in.
Correct. You're actually taking this away, and by taking it away, we mean subtracting.
This is one.
So transitive would have to say 1 equals 2 and 2 equals 3. So then 1 equals 3. Jonathan.
Wait, so if I got this right, it'd be substitution because it's an equation.
It's because you're replacing a single thing with more than a single thing, or a value with an object. Yeah. All right, congruent complements theorem is pretty much the same thing as the congruent supplements, except instead of 180, it's 90 degrees. If two angles are complements to the same angle or to congruent angles, then they are congruent. So if the measure of angle 1 and 2 are complementary and 3 and 2 are complementary, then 1 and 3 are complementary because of this theorem, congruent complements theorem.
So it's just telling us that.
All right. Postulate 2.8, okay, is called the linear pair postulate. So we have actually used this without knowing its name, but it says two angles that form a linear pair are supplementary. So we know if two angles form a line, right, if the outside angles, the non-shared side of those angles, form a straight line or a straight angle, then they add up to 180, and 180 means they're supplementary. This puts those two things together. So linear pair postulate, which we do actually abbreviate as LPP, because we use this one a lot, says if two angles form a line or form a linear pair, then they are supplementary. All right, and then vertical angles. So we know the definition of a vertical angle. These are two angles such that the sides of one angle are opposite rays to the side of the other. Hopefully we remember this. That is the definition of a vertical angle. So just by looking at this diagram, you should be able to tell me that 2 and 4 are vertical angles and 1 and 3 are vertical angles. That's the definition of them.
So how do we tell if they're vertical if there's not a diagram like that?
There has to be a diagram.
Oh.
Yeah, they have to give you some sort of diagram. And if there's more than one line somewhere, you literally extend out the sides of the first angle. And if that forms the second angle, then they're vertical angles. And then we take it one step further now. And now we say the vertical angles congruence theorem, which we shorten into VAT, vertical angle theorem. Okay? And that says all vertical angles are congruent. So the definition just says what they are. The actual theorem says that they're congruent. So in that diagram, the measure of angle 3 and 1 would be equal to each other, and the measure of angle 2 and 4 would be equal to each other. And that reason would be vertical angle theorem, or VAT. All right, this is a paragraph proof. So remember the paragraph proof has all the words. It says use the given paragraph proof to write the two-column proof of the vertical congruence theorem. Given angles 5 and 7 are vertical angles, prove that angle 5 and angle 7 are congruent. And the paragraph is like kind of like a plan for that proof. It's saying...
Are you going to make us do this on the test?
A paragraph proof? Heck no, I don't want to grade that. Yes. Yeah. It says angle 5 and angle 7 are vertical angles formed by intersecting lines. And 5 and 6 are a linear pair. And 6 and 7 are a linear pair. So then by the linear pair postulate, 5 and 6 are supplementary and 6 and 7 are supplementary. So by the congruent supplements theorem, 5 is congruent to angle 7. That is just one way to prove it, okay? You could literally prove this by having nothing other than the picture and the labeled angles. So we're going to build a two-column proof of this, okay? So we're going to start with the given information. We're going to start with the given, which is that Angle 5 and angle 7 are vertical angles. This time, though, that is not just given. That is the definition of vertical angles.
Wait, so how come it's not given to us?
Because there is nothing given to you. The diagram is what tells you that.
Also, it has to say given next to it for it to be given.
I said we don't even need this. We're going to go off of the diagram. You can, if you went off of that, I would use it. But you can do this without having a given if you just have the diagram. Okay, so again, now that I know VAT, I could literally go to 2 and write angle 5 is congruent to angle 7, and the reason is vertical angles theorem. But we're going to prove it without knowing that. So based on that diagram that is there, what kinds of relationships can you set up outside of the vertical angles theorem? What is supplementary?
Angle 5 and angle 7.
Angle 5 and what?
And angle 6.
And angle 6 are supplementary. And how do you know that? Because they form a linear pair, and a linear pair are supplementary. That's linear pair postulate. The linear pair postulate. So just that they're supplementary means that they add up to 180, which you're not getting that from the diagram. The diagram is telling you that they form a line, and then that makes them supplementary. That's linear pair postulate. So if you're using the diagram to get that they're supplementary, that's linear pair postulate. What else would be supplementary?
7 and 6.
Angle 6 and angle 7 are supplementary. Is it the same reason?
Yeah.
So I don't even have to separate them out. Okay, I could put them as the same statement.
So they could both be number 2.
Yeah, as long as they have the same reason. Yep. Now what? Because there's 2 ways to do it from here.
Transitive property, 5 plus 6 is equal to 6 plus 7, and 5 equals 7.
How did you get to that they equal each other?
Transitive property.
Transitive would be if 5 equals 6 and 6 equals 7.
Substitution. Subtraction? It's like Mark said.
You're like 2 steps from where you need to be if you're going to do it that way. First, you have to set up that equals something, right? What does supplementary mean? 180. So you can say that. I could say the measure of angle 5 plus the measure of angle 6 equals 180. And I can say the measure of angle 6 plus the measure of angle 7 equals 180. And that's the definition.
That of supplementary.
Correct.
How does Mark say?
And then I can say what? I can say that 5 plus 6 equals 6
Wait, why are you putting the M?
measure.
Do you have to put that?
No. I just started that way, so I might as well just continue. And that's substitution because they both equal 180.
Oh, and
Then subtraction.
Then I can take away what?
the 6, so you subtract 6.
So angle 6 equals angle 6 would be what?
Subtraction.
Not yet.
Oh, no.
Reflexive. Then I can say 5 equals 7, and that's subtraction.
Can't you not?
Do
Do you have to be reflexive?
I'm going to say if it's part of your built-in steps, obviously you need to give it its reason, but because it's the same thing, no, you don't have to. Okay, but I could do this shorter. If you read the paragraph proof, it hints you how to do it.
Can you just go from substitution to the subtraction?
But that's what they just asked. And I said yes, but keep in mind that sometimes that step's going to be there and you need to have the reason.
So like if I did this on
Oh, well,
this side,
since 5 and 7 are equal in degrees, can't we just say that they're vertical angles?
No. So from here, if you read the paragraph proof, it says if 2 angles are supplements of the same angle, they are congruent, right?
Yeah.
And that is
A linear.
Congruent supplements theorem. So I could have gone step 1, step 2, then step 3, angle 5 is equal to angle 7. And the reason is congruent supplements theorem. It doesn't mean the right side is wrong.
That's what I was trying to say.
Wait, then why'd you do 3%?
I said that's one way to do it.
You choose.
They're both
So
right.
you don't have to
No, I only did that because that was the suggested step. That's why I went that route, because it's not wrong. It's not wrong, it's still right, okay? There's no reward for getting it done in 3 steps instead of 6.
So like if I just I'm like curious if I do it that way, the long way,
Yeah,
and I don't do step 5, will I get marked off?
no,
So it's 3 with you,
sure,
but you just decided to do it actually.
yes. They are all right. They are both right, Sophia.
Can I ask that?
Mm-hmm. All right, you try this one. All right, we said these equal to each other because they are vertical angles. Vertical angles are congruent. We solve for x. Okay, example 7, classify each statement as true or
You
false.
just do it. You don't even prove it.
Correct.
Yay.
Number 1, if the measure of angle A plus the measure of angle B plus the measure of angle C equal 180 degrees, then A, B, and C are supplementary. True or false?
True.
Oh, such a trick question.
False.
Why is it false? Do you know?
Because you can only have 2.
Yep. Supplements are only in pairs.
That's why they're called linear pairs.
2 vertical angles have the same measure. True or false?
Wait, say it.
True. Vertical angles have the same measure.
Oh,
True. And 3, if angle 1 and angle 2 are vertical angles and the measure of angle 1 equals 2x plus 8 and 2 equals 3x plus 4, x equals 14. So we'd have to set them equal to each other. 2x plus 8 would have to equal 3x plus 4.
actually, no, that's false. Wait.
X should equal 4, not 14. This is false. Love the sound effects. Questions? So I think there are questions in the homework. There are definitely questions on the review and the test that when you get to the angles, you have to remember that if they are vertical angles, they are equal to each other. So if I got those two, I would set them equal to each other. But if they are next to each other, then I add them up and set them equal to 180 because they're supplements, okay? So you're going to see both pairs of relationships. If your question has an equation in it, you must show me some work and then submit it.
Oh my God.
Yes.